Today we're going to cover how to set up your 3D printing files in the Cura software so that you can submit them to the School of Architecture's website and have them printed in the Fabrication Lab. The first thing we're going to do is set up Cura. So on this computer, I've installed Cura, but I haven't done any setup yet. So we're going to click to open Cura. And when it opens, it's going to ask us if we want to install the machines and make sure I get everything set up. So the first thing we'll do is click Get Started. Click agree. We can move kind of quickly through this menu. Here, you'll see that there's an option to add network printers. If you're doing this on your own laptop, you're not going to see these as an option. These are only on the school's network. And you don't need to install the school's 3D printers to submit your files. So we're going to go ahead and go to add a non-network printer. At the school, we have Ultimaker S5 and the Ultimaker 3 Extended. So depending on the size of your print, you're going to want to install either the Ultimaker 3 Extended or the Ultimaker S5, or you can install both on your machine depending on which file types you might be printing in the future. So we're going to go ahead and click Ultimaker 3 Extended and click Next. This will now load a generic Ultimaker 3 Extended machine so that you can bring your files in. I'm going to go ahead and add the Ultimaker S5 just so that you can see how you have both of those printers. So if we go over to the box over here where it has preset printers, we can go ahead and click Add Printer. And here in the same way, we'll go back to Add a Non-Network Printer. And we can go to Ultimaker S5 and click Add. So now you can see that made the print bed a little bit larger, which is the S5s are a larger machine, the larger print bed, but we can toggle back and forth between those two by coming over to the left-hand corner of the screen and moving between Ultimaker 3 and Ultimaker 5. Next to the machine, you'll have options for setting the different types of material. You can set PLAs, you can do it by Ultimaker specific materials or more generic materials. For your purposes in submitting it to the Fabrication Lab, you do not need to set any of these materials. At the end of the video, we'll go over some of these things, but all of this stuff will be set up by the lab technician. So you'll really just be setting up the type of machine you want, again, whether that's the Ultimaker S5 or the 3 Extended, and making sure that your files import to scale, and you'll save that file and submit it. To try to educate a little bit on some of the other settings that we set up in the lab, I'll go through those at the end. But again, don't worry about trying to understand all of that right now. Really, we're just trying to get you able to bring your files in and submit those. So the next thing we're going to want to do is bring in our file. When you're exporting from Rhino or Revit or whatever different type of 3D modeling software you're going to use, you want to make sure that you're exporting in the units that match the Cura file, which is going to be in millimeters. So I've exported two different file types, one in inches and one in millimeters. So if we go over to File, Open, go to my desktop, and we'll pull out the space file in millimeters. So you can see here, this space is appropriately scaled. It's about the largest thing that we can print on the bed size that we currently have, but it seems to fit. And you can tell if the object fits because it will turn yellow. If we move this file over and we're somewhere out here, or if your file is too big, you'll get this kind of yellow and gray striped pattern, which essentially says that the file is not able to be printed. Sometimes it's as easy as just moving it on the location of the build plate, but in other cases, it might symbol that your model is not quite the right size. I'm going to actually go ahead and delete this for right now. And I'm going to go ahead and re-import a new file, which is my base that was exported in inches. So both of those were modeled at the same size. It was about 6 inches, and then I converted the file to millimeters and just exported those. However, this now is taking my model and leaving it, or sorry, automatically converting it to millimeters. So it's saying it was 6 inches in the file, I'm going to make it 6 millimeters, rather than doing the actual translation to bring it in at the appropriate size. And so this is the reason you want to make sure you're setting your file type to millimeters and exporting as a millimeter file type when you are finished with the program. So again, this was exported. It should be in Rhino the same size if I imported both those models back in, but Cura doesn't translate from inches to millimeters correctly. It's just going to automatically assign the numerical value for the imperial system to the metric. So 6 inches will become 6 millimeters and your files are going to become way too small. So I'm going to delete this, go back, and I'm going to re-import the base that's in millimeters. And that again is going to come in at the appropriate size. So once you have your model brought in, if we look at the left-hand side of the screen over here, you have your different options to move the file. You can kind of use this gumball to move it forward, backwards, up and down, or you can numerically move it in millimeters if you wanted to move it, let's say 2 millimeters up in Z. Sorry, it's going to make it so that your model is always on the build plate. Let's say if we want to move this in Y, we can move this to 18, and you'll see that move. If we go back to 15, you'll see your model move around. So you can kind of manually type in millimeters if you want to move the file around. Similarly, you can scale the file. I'm not going to mess with this because I don't want my project to be at a different scale, but if you wanted to go through, you can adjust it in percentages. If you said you wanted your X value to be 150 millimeters, you can manually type those in. And here you can use that to uniformly scale, or you can do snap scaling where you're only scaling one dimension, which would be similar to a scale 1D command in Rhino. Similarly, you can rotate and use this to adjust your model. There might be different reasons you want to do that in terms of supports. But for our cases here, we don't really need to rotate it. But again, you could kind of manually rotate here. It, I believe, snaps to about a 15-degree rotation per turn. So you can move through those rotations and get back to the layout that you want. You also have some options to mirror the file, and you can start to get into some of the meshing types, showing you what some of these supports might look like if you're doing infill meshes only, if you're leaving the overhangs out. Again, these are more so kind of visual cues, and you don't really need to adjust any of these. You also down here will have some options for looking at the material support. These will map automatically to the types of material that you're setting in the box up here. So I'm going to go back here, adjust my mesh type back. So as a student, now that you've imported your model in, you know that it's correctly scaled, it looks right. This is really all that we're going to ask you to do when you're submitting your file into the Fabrication Lab through the School of Architecture website. So all you would have to do now is go to File, Save Project. Again, you want to make sure that the printer is right so that when the Fabrication Lab monitors are sending it to print, they're sending it to the right printer. If you set it up for an S5 printer, that's much bigger, but it gets submitted as an S3, then there's going to be issues because that machine might not be able to print the same size. For all of the extruder, the print core, and the material, don't worry about that. We'll adjust all those in the lab. And similarly, for the profile settings, we have all those settings preset for the lab. And so we'll take care of importing that. Once we load it on our computer, we can set all of those settings for you. We'll hit save. We can save this, let's say 3D print. And you'll notice here it's saving this as a Cura project 3MF file. This is the type of file that you want to be submitting. You'll get a different type of file if you move forward the whole process and slice your model, which will be an Ultimaker packaged file, which is not the file type that we need. We'll go ahead and hit save. Once you have that file saved, again, you can go to the Fabrication Lab website on the University of Miami School of Architecture website and follow the steps to submit that file to the lab. Now, I'll go over a little bit more about the materials that we have in the lab and the type of settings we'll use to give you an idea of how that works. But again, this is the only step you need to do to submit your file to the lab. But if we move forward past that, as I mentioned, you have the option to set different types of materials up here. In the lab, we always provide the tough white PLA by Ultimaker as our default standard material, and our print core is 0.4. This is talking about the resolution. So the larger that you move up in this print core size, the more filament is going to come out, and you'll lose a little bit of resolution. So typically, you can alternate between 0.25 and 0.8. We do 0.4 as a kind of nice balance, a trade-off between speed and resolution. But if you wanted to find a different type of PLA online, or you wanted to try a different type of material, you're always welcome to bring those into the lab. And so in there, you can go through and find some of these other materials you might want to use. We often have different colored PLAs. We printed with some nylons and some ABS. And so you'll go through and figure out these different types of materials and what you want to print with. and you can always set that up. Again, though, for our lab, we're always going to be using the tough white PLA, so we'll set that there. Now, the second type of material we use in the lab is PVA, which only comes with natural PVA. This is a material that can essentially be washed away. It's water soluble, so you can submerge your print usually for about 16 to 24 hours, and it will dissolve the supports. Now, that takes a long time to dissolve and can be quite a little bit tricky when you're trying to make sure that you get a really clean surface. So typically, if you can print a support that's made out of the same material, they're usually easier and quicker to peel off the support material. That would be, again, to set the support material as another tough white PLA. But alternatively, if you have a very complex shape or something where you can't reach the supports, it might be a good idea to select PVA because you can always wash that through. A good example of this would be if you were 3D printing some sort of pipe that needed fluid to move through it, and you couldn't reach the inside of the pipe, you might want to use the PVA where you could submerge that and have the water dissolve the internal supports that you need. Whereas if you did that out of a PLA, you're obviously not going to be able to reach the inside of a small pipe to be able to pull those components out. So once you have those materials set, you can go over here and we'll go through what some of these adjustments are. Ultimaker and Cura do a great job of setting a lot of different preset values for a lot of these things, but the main kind of values you want to pay attention to are the profile, which is essentially how thick each layer that you're printing is. 0.1 is pretty good resolution. 0.2 is not going to be as great of a resolution, but it's going to print much quicker. So here they have some kind of default set for kind of standard printing. If you're engineering, you might want a lower or a finer resolution. Visual, you might want a very fine resolution. If you're drafting something, it just means you want to print it to kind of get a sense of the scale, see if the object is the right form. You'll move that up to the 0.2, which will allow you to print much quicker. Similarly, you have infill, which is essentially how dense the inside of your model will be. So if we're looking at this model, you can see that you have this profile that goes through. The printer is not going to print it solid unless you tell it to, which would be setting it to 100%. Anything lower than that, you'll see this box go from a solid to a dense mesh, essentially. And so it'll go through and infill that for you. The lower the infill value is, the easier it will be to break and the less tough it will be, but it will print significantly faster. Here you can also generate supports, and then you can let it know whether or not you want to use extruder 1 or extruder 2. If the materials are the same as we currently have set up, you could do either. If you were going to use a PVA and a PLA together, you would select extruder 2 where we have the PVA set up. These are just the kind of basic default print settings. If we go into custom, we can see these a little bit more clearly. So here we have quality. Again, quality is mainly talking about what that layer height is. And so typically we're looking at printing between a 0.15 and a 0.2. If we don't change anything else in the model, let's say we just make this a 0.1 and test slicing it. This is essentially going through and slicing the model now into layers that are 0.1 millimeters tall. And so as you can imagine, with an object that's this tall, this is adding in a lot of layers, which is why it's taking so long to slice. So we see that that's going to be a 6-day print. If we just adjust only that setting, we can go back through and slice. You'll see this is already moving a little bit quicker. It's essentially cutting those layers in half. And so we should get a significantly lower print time. So here we get just about half of that, where we're printing this in 3 days rather than in 6 days. So this is really something that you can use to control the speed of the print. If you're doing 3D prints as a kind of test and you're really just trying to get a rough idea of the geometry that you're working with, always move that up and try to be in that 0.2 range. So that way we can print the objects much quicker. Similarly, you can set shell, which essentially will set the wall thickness. As we mentioned earlier, you have that infill. And so between that infill, you have the wall on either side. And so this will actually let you control how thick the wall is before it moves into that infill density. And again, the more that you increase this, the more solid the print is going to be, but it will also be a trade-off in how long that's going to print. If we go to infill, again, this was at 20%. If we move this back up to, let's say, 80%, we can see what that will do to the slice time. Within the infill density, you also have options on how it's infilling. This might have a little bit of an effect on the structural performance of the project. For most of these types of prints that we're doing with PLA, it's not going to have a huge impact on it, but you might want to, if you know something is going to be compressed in one direction, you might want to use a grid that's going in the counter direction, or you might want to triangulate it. There's a lot of different options that you can do. So for this object, we just got the slice time back. It looks like it didn't change significantly. But again, this object is pretty thin, so you don't have that much space that it's filling with its infill density. If you had a large cube that you were printing and you went from a 20% infill to 100% infill, that's going to significantly increase the time it will take for it to print. We also have the material setting. So one of the kind of key settings for the material will be the temperature. Ultimaker, if you select their material, they'll provide you a pretty well regulated standard for what temperature each material should be printed at. But this is something that can be a little bit finicky depending on the temperature in the room, the humidity in the room, and a lot of other temperamental factors. And so you might need to adjust this a little bit based on where the machine is located. In the Fab Lab, we've had our own setup and kind of adjusted these numbers as we need to. You also can set the print speed. This is something that's related to the material temperature and the kind of flow rate. The faster the print is moving, you need to have the material coming through. But if it's at too low of a temperature, you're not going to get enough material coming to match the speed. So there's going to be, again, a trade-off between speed, material temperature, and the flow rate, and making sure all of those kind of work together. Typically, the speed doesn't need to be adjusted very much. Travel, this just kind of gives you a little bit of control of how the machine's moving. If it's retracting above something, this comes into play more so when you start to have different nozzles. As we have the two different extruders, you can set different nozzle types. And so you need to enable this if you want the printer to be able to adjust that. Again, this is a setting that you're really not going to get into too much, so I wouldn't worry too much about understanding the ins and outs of that. The main other ones we'll go through really will be the support. So again, we have the option to generate support. You can select which type of extruder you want to support. If it's the same material, you can just use the same extruder 1. If it's a different material, you can alternate and move into extruder 2. There's another kind of important aspect of this is where it's placing the supports. And so if you place the supports everywhere, it will essentially allow the print to support everywhere in the model that needs support. So in this model, a good example of that would be if we zoom in on some of these segments, you can imagine that you might want to have some supports that are coming in and supporting the areas in between here. And so if we set that to everywhere, you'll get those supports coming in. If we set that to just touching the build plate, it will only put supports in locations where it can go all the way down to the build plate. So you'll get full support underneath here and even in some of those perforations. But anywhere once you kind of reach that maximum width of the model, you won't have any supports that are getting filled in these areas that I'll color in red, as if they don't have a way to move straight down and touch the build plate. So in some models, that's okay. You might not need that everywhere. In other places, you might want to. It just gives you one kind of lever of control when you're adjusting how the supports are being placed in the model. Build plate adhesion. This again will talk about how it's going to mount your model to the print. If you've seen some images of different types of 3D prints, you'll notice there's typically a little skirt. This essentially puts on a thin layer of material that starts to get the material adhesed to the bed before it starts printing your model. If you don't have anything, you're essentially trying to bet that the first line of that PLA coming down is going to stick perfectly. And if that doesn't happen, it can mess up the entire model. So typically you'll have one of these skirts that will allow the printer to kind of warm up and start printing before it gets into the kind of critical material of your print. The other thing this will do is it will help hold your print down. In this case, the skirt is going to surround the entire print, kind of two-dimensional offset. This will help act as something that gives it more support, holds that bottom layer down. In PLA printing, you often get a kind of warping that happens on the bottom where your surface will start to peel up as you have your print finish. So you might start to get a little bit of warpage, whereas the material started to cool off, it's actually pulling up and pulling off the build plate. If you leave one of these skirts on, it will essentially give you more print that's offset from here and help make sure that this is holding your print down and giving you better adhesion to the build plate. There's a few different other types. You can do wraps, you can do brims. We won't go into those in too much detail. Essentially, they're just different versions of setting that skirt up. They have a small amount of effect on the build time, but really, unless you have something that's taking up the entire build plate, there's not going to be a huge difference or a huge trade-off between those different options. Finally, we have dual extrusion. This essentially is just talking about having both of those extrusions going at the same time, which you can enable if you have this extruder 2 going. And this will allow both materials to be extruding at the same time. So again, those are the different types of settings that you'll adjust when you get into 3D printing. Again, Cura has a lot of default profiles. You can do fine, normal, fast, extra fine, and these will kind of control all of those different settings that we've looked at together, but in a way that's been kind of fine-tuned from Cura, and they think that they are pretty good settings. Again, when you get into 3D printing on your own, or if you purchase a 3D printer for your home, you might need to go through and adjust some of these settings yourself. But for the most part, those settings should work as a kind of base default line. Once you have all of that set, you can go through and slice the model. This is the part that's essentially creating the G code that's going to tell the printer where it needs to move and how it needs to move. The reason we don't have you go through all of the settings and all of that setup and slice it and submit the G code directly to us is because we, again, have a little bit different settings, and it'll be a lot of work for every student to learn all the different settings that we use and how to adjust that. But also, if there's any issues between the different types of material that you have set, or if you have a different machine set up, it won't let you change any of that. The G code will package itself and say, this is the specific machine that I'm meant to print on. This is the specific material I have to print on. And then it'll just be a series of coordinates that's telling the printer, go to this location, go to this location, go to this location, and all the way throughout the printer. Once you do that, it's already been generated. There's not a way to go back in and really alter that information. Whereas if you just save the Cura file, even if you've made a mistake on the setup, or you have different materials, or you have generic materials set up, the Fab Lab monitors can go through, adjust that for our materials and adjust that for our settings, and they can go ahead and slice it, and then they can send that to the printer. If you want to get a sense for yourself on how fast it's going to print or how long it might take, you can obviously go ahead and slice the model for yourself. That should give you a rough estimate. Again, it'll likely change before it's printed because we'll have different settings based on the materials that we're using. But this is just a way for you to give yourself a kind of understanding of, is it a 1-day print? Is it an 8-hour print? Is it a 3-hour print? Kind of plan your process accordingly. And so again, while this is slicing, what we want you to submit to the lab is just saving the Cura project up here. So just going to File, Save Project. When this slices, I'll show you quickly how to set the G code and save that if you were going to print this on your own machine. So here you can go over here and go to Save to Removable. And this is going to save this to a flash drive that I have plugged in my computer. Or alternatively, you can go to Save to a File and save it anywhere on your computer, on the desktop, or wherever you may want to store that. Again, This type of saving is saving the G code. This is not the file that we need at the lab. This is just if you were going to print this at yourself on your own machine, or if you want to get a sense of how much material this is using and how long that print might take. There's some other tools. If you want to get more involved in 3D printing, you can use some of the options to look at previews. These will essentially allow you to see what the different layers look like and allow you to slice through the model a little bit more interactively. So here you can kind of go through and adjust. This will show you where the printer is moving and go throughout that file. So this is going to show you each layer as it prints. And if you adjust this bar over here, you can go through and slice through that model and see the different components. This can be a helpful tool if you're printing a more complex geometry and you want to get a sense of where you might have some of the issues in your file, or if you might want to look more interactively at the different types of infill meshing that you're doing or supports that you're doing and see if there's areas that are causing you issues. You can also go to this monitor. Again, these are not connected to the printer, but when you have your own printer set up, or if you're working in the Fabrication Lab, this will link you to all of the other printers and you can kind of interactively see videos of the model printing, or you can see what types of files have been sent, kind of get a little bit more information on the actual printers themselves. But again, there's a lot more information you can go into this. The manuals that we have uploaded to the Fabrication Lab website should go through these kind of step-by-step and show you a little bit more information about this if you want to go a little bit slower. But we wanted to give you a little bit of an overview of how the 3D printing software works in Cura. And again, just one final reminder, make sure when you're submitting your file, you go to File, Save Project. You're going to want to save as this 3MF and submit that to the lab. The reason we want you to submit the Cura file rather than the STL is just to make sure you've brought it in and you feel that the scale is appropriate. Again, the importing in inches versus millimeters throws a lot of students off the first couple of times to 3D printing. And so we don't want to have you accidentally bring a model in or export a model as an STL that's scaled wrong, and we bring it in and we accidentally print it at the wrong scale. We want to give you a little bit more control over those models and allow you to kind of scale them and adjust them as you see fit. And then we'll go through the kind of final settings of adjusting what materials used and what the kind of final print settings are. You'll also see in the next week or so, we should update the Cinder 3D printers, which are a new 3D printer, very similar to the Ultimakers that we have. And those you will be operating as your own on a student. And so the softwares will be very similar between the two. But we wanted to give you a background on how all of these different softwares work so you can start to understand that process. If you have any other questions, please feel free to talk to any of the Fabrication Lab monitors or reach out via email. We're happy to answer any questions that we can or provide any more information or training that we can to you as students.